applications of coordination compounds. There are a series of applications given in the syllabus. Now we are going to discuss about one by one the applications of coordination compounds. First one, qualitative and quantitative analysis. So in what way the qualitative and qualitative analysis in this process, how the coordination compounds are going to be helpful. So first we must know what is this qualitative and quantitative. Qualitative means it is going to tell us what type of ions are there by using these coordination compounds. Quantitative means how much amount of ions are there in this particular in any solution. In any solution, what type of ions are there? That can be determined by using this coordination compound chemistry, right? And enabling the identification and measurement of the metal ions through complex formation and color changes as well as titration techniques, right? Here, during complex formation and color changes, we can identify what type of metals are present in the solution. For example, a solution is there. A solution contains a solution is there. In that one, if you are adding something called ligand, and if a solution contains a metal, that forms surely a metal ligand. This metal ligand will give us indication by changing its color or complex formation as well. Based on these factors, we are going to find out the qualitative and this is going to be helpful in the qualitative and quantitative analysis, right? Now we are going to discuss about qualitative analysis. That means qualitative means already I have discussed. Qualitative means what type of metals are present in the solution, right? Right. For example, in a solution, we don't know what type of metal is there. In a solution, we don't know what type of metal is there, right? And to the solution, we are going to add ammonia. So we are going to test what type of metals are present in the solution. How? By adding ammonia. By adding ammonia, if you are testing, surely this metal is going to form some complex with this ammonia. When if the metal is copper, what type of complex is going to form? Copper going to combine with 4 ammonia molecules in this way. So this will result what color? Blue color. It will give you blue color. So formation of blue color by adding ammonia will give you a complex that is a tetraamine copper. Tetraamine copper plus 2. It is going to form. This complex is going to give you a blue color. The formation of blue color is going to indicate us the presence of metal is copper. If the metal is not copper, it will not give us the blue color because we are adding ammonia. If the metal is copper only, it will give us blue color. In this way, we can identify the metal present in the solution. This is one example. We are going to discuss more examples also. So one example, if what is the metal which is present in the solution, just add what ammonia. If the color is going to be blue, that is going to be copper. So identification of copper is very easy. In this way, the complex formation is helping us to identify the metal ion, and identifying the metal ion by using a complex is called as qualitative analysis here. And now let us look at what type of metal ions are there in the water. We all know that in water magnesium ions and calcium ions will be there. That causes hardness also. Imagine magnesium and calcium are forming hardness. Obviously, they are causing hardness. They are a hardness causing salts, and they are there in the water. Now, how to know in water whether calcium or magnesium ions are there? By with naked eye, we cannot see. In a water, if you are looking in the water, we cannot find out which ions are there in the water. Then how to find out the ions which are present in the water? We have to add some chelating agent. Already we discussed What is the meaning of chelating agent? Chelating agent is the one which is having more than 2 binding sites. Here we can see 1, 2, 3, 4, 5. Sorry, this is not going to be 1, 2, 3 and 4 and 5 and 6. You see 6 are binding sites. These 6 binding sites are there. The 6 binding sites are there. Ethylene diamine tetraacetate. Ethylene diamine tetraacetate. What will be there? COO minus. COO minus tetraacetate. How many binding sites? 6 binding sites we have discussed. COO minus. COO minus. If you are looking into carefully, here this is going to be one binding site, second binding site, third binding site, 4, 5, 6, 6, and 6 binding sites are there. So this can be called as hexadentate ligand. What is the meaning of 6 hexa? And as it's containing 6 ligands, right, this will be called as hexadentate ligand. So this hexadentate ligand is going to help us to find out what type of ions are there in the water. How? By forming a complex. Why? Because they can act as binding sites. For example, a metal or a magnesium ion. If magnesium ion is there, this can form complex in this way. In order to show this complex very easily, we have taken this image. In this image, is very clear that how the central atom is coordinated with 6 binding sites. The 6 binding sites I showed you separately also now. So these 6 binding sites are going to form a complex with magnesium ion. Imagine now magnesium ion is going to form complex with EDTA and EDTA. What is meaning of EDTA? Ethylene diamine tetraacetate. That is structure of this. So once after forming this complex, this will give us indication with color changes. How? Actually EDTA is not color. EDTA is colorless only. Then how to identify the formation of EDTA with magnesium ion? Just add EDTA to the water which is containing magnesium ions. Surely it will form a complex. Why? Because having a capacity to form complex with the magnesium ions. But we cannot identify the complex formation by using it our naked eye. So what to add? We will add some indicator. What is the role of indicator? Indicator role is which will give us color change when something is happening there. So indicator will give us an indication that there is a complex formation while you are adding some indicator like electron black tea. So that's the procedure. Electron black tea will add the color change will come from electron black tea will be blue and it will color change to wine red and again it will color change to blue in color. So wine red to blue color will happen during the titration. But that is not important here because it's a qualitative analysis. Qualitative analysis will give us indication that there are some ions present in the water. So to find out the ions present in the water, we can add EDTA and that forms a color, that forms a complex. If you are adding indicator, we'll be able to see ions are there in the water. In that way, this reduction of metal ions also we can find out. And what type of complexes we have to send out? We have to send a complex which can form complex with magnesium ions or calcium ions because in the water. In this way, EDTA is going to help us to find out the hardness that we are going to discuss in the quantitative analysis. This is qualitative only. Which ions are there? Calcium and magnesium can be identified by using EDTA. And in what to call solution, in solution, how to identify copper, add ammonia and see the color change as blue color. In this way, the qualitative analysis applications are there during the formation of complex. Now, quantitative analysis. What is the meaning of quantitative? How much amount is there? Previously, we have discussed based on color changes, we can identify which metals are there. Now, based on color changes, Along with the color changes, we are going to find out how much amount is there. For that, there are different titrations. What is the meaning of titration here? Titration means to find out the concentration of unknown. Titration means to find out the concentration of unknown. What is the unknown here? That is the metals present in the solution. What metals are there? That will give you qualitative. How much is there? That will give you by quantitative. So to find out how much is there, we are going to do the titration, right? So coordination compounds are going to be play an important role in the finding concentration of metal ions in a solution. How much metal is there in a solution? That is going to be find out by this particular method called titration. So titration means to find out the concentration of unknown. Unknown means here metal, right? So in a solution, how we are going to find out titration? And we are going to, for example, a water is going to contain some magnesium ions, of course, calcium ions. Water is going to contain some magnesium ions or calcium ions. We are going to add some complex called EBT. This EBT is going to be blue in color. What is EBT? Indicator. Why we are going to add indicator? Because we have to observe color change. By adding directly EBTA, we cannot observe color change. So once after adding EBT, the water will change to EBT with magnesium. This color is going to be wine red. So the color changes are very important. So this wine red color solution, we will take it and we will titrate against EBTA. How? In a conical, we will take EBT plus water. Of course, we will add some buffer to resist the change in pH value, because this is pH dependent experiment, and we will titrate against EBTA. In this burette, we will take EBTA because we want to find out how much magnesium or calcium is there in water. To find out that, we are going to see how much EBTA is going to be consumed. This process is called as titration. So during this titration, what happens? What color I told you? EBT plus water plus buffer will give us a wine red color. This wine red color, while doing titration with EBTA, what happens? This EBT formed a complex, right, with magnesium ion. This EBTA will have 6 chelating sites. How many? 6 chelating sites. Whereas EBT will have 4 chelating sites. So EBT will be pushed by EBTA. And then this magnesium ions will be taken by EBTA. And what happens? This EBT will be out. What is the color of EBT? I told you, blue color. So the color will change from wine red to blue during this titration. Wine red to blue. So based on the color formation like blue color, we can understand that EBTA formed a complex with magnesium ion, because EBT came out, right? Based on the color of EBT, we can understand that EBTA formed a complex with magnesium ion. So by doing some calculations, we can find out how much EBTA is consumed to react with the magnesium present in the water. That way, we will be finding out how much hardness is there. Hardness means what? How many magnesium ions are there? This hardness will be expressed in terms of ppm, parts per million. So, or milligram per liter. What it will give? How much amount of magnesium ions or calcium ions present in the water, will be given by this titration. And so, in this way, we are going to find out how much amount. That means quantity. What is the meaning of quantitative? How much amount is there? Quantitative by EDTA method. As EDTA is forming, what it's forming? A complex during this titration. So it is called as a complexometric titration. Complexometric titration. Why it is called as complexometric titration? Because EDTA is forming a complex during this particular process. In this way, we can find out how much magnesium and calcium ions are there in the water. Now, same way, how much we have discussed already in a solution. In a solution, if copper is there, how to identify? Add ammonia. Look at the color. It will be blue color. But that is qualitative. But if someone is asking, tell me how much copper is there, that will give you quantitative. How to identify? Nothing. Prepare a different solutions in which copper, in which a solution is going to have different concentrations of copper and ammonia. So you prepare a solutions just like Jobs method. Prepare a solutions in which copper or this solution content is varying and ammonia content let it be constant. We are adding equal ligand concentration that is constant and metal concentration we are going to vary. So we will prepare a series of solutions. How? For example, here we are taking 5 ml of copper sulfate solution and we are adding 5 ml of ammonia. Ammonia means ammonium hydroxide only, ammonia solution. 10 ml of copper sulfate and 5 ml of ammonia. 15 ml of copper sulfate and 5 ml of ammonia. What is the meaning of sulfate? Because copper will be with sulfates, right? We are adding copper sulfate and we are adding 5 ml. So prepare a series of solutions and then draw a graph between absorbance versus volume of copper sulfate. Volume of copper sulfate with ammonia. If you are mentioning, right, if you are seeing, looking at the graph, if you are varying the, what to call, different concentrations, what happens? This will vary. And what is this actually? This will go through origin in this way. So, here we can find out by drawing a graph wherever our unknown volume is exactly matching with the volume of the absorbance. Based on this absorbance value, we can find out by drawing this graph, we will get a graph like this. Whatever concentration we want to know, we can find out the particular volumes solution by using this graph. So, in this way, colorimetry experiment will help us to find out the copper present in the solution. This is qualitative and quantitative. Now we are going to discuss about applications of coordination compounds in medicine for removal of toxic metal ions. What type of metal ions we are going to remove by using this complex symmetric method? What is the meaning of removal? Just we are adding a metal ion or ligand to the metals which are present in the body and we are taking out, right? In that way we are going to remove. How? Because the metal which is there in the body or somewhere which is causing harm to us, that is going to form some bond with our ligands. We are going to add ligands only. So now the process of using coordination compounds, specifically chelating ligands. Why? Because the chelating ligands will form bonds. The chelating ligands will form bonds like this. With what? Metal ion. The chelating ligands will form a bond with metal ion. Imagine this is a metal which is there in the body. We are sending a ligand and ligand is going to form a bond, and after this this is going to form a complex. This complex will be out through some processes. We will discuss about that process. So in this way, this metal is going to be out from our body, right? So chelation therapy, chelating ligands to bind and remove heavy metals. Imagine already we have discussed ethylene diamine tetraestate. How many chelating sites we have discussed? We have discussed about 6 chelating sites, right? 6 chelating sites. 6 chelating sites. These 6 chelating sites, 6 chelating sites, we are going to form a calcium disodium EDTA complex. Calcium disodium EDTA complex, we are just going to add to the, right? We are going to add, and then what is going to happen inside body? Inside body, if for example, imagine lead is there. If you are adding this particular complex, what is going to form? It is going to be replaced and going to form lead disodium EDTA. Very important thing is this lead disodium EDTA is more stable than this one. Obviously, whenever we are adding complex, right, we are going to have add a less stable complex to the to trap this so-called lead or toxic elements, and this complex will form other stable complex with lead, and it will allow the calcium will be out in this body. Anyway, calcium will not do any harm to us, right? And this particular lead will trap here, it will stable. What will happen? It will come through urine. So this lead will form a complex that will come through urine. So lead will be out of our body. In this way, this chelation therapy is going to help us to remove the toxic metal ions present in the body. Next, one more thing, removal of copper ions present in the liver. Imagine in liver copper ions are there. How to remove? You send a ligand which can form a complex with our copper, and that will be out. We cannot take ammonia. We cannot take all the ligands which can form complexes. We have to take some ligands which will not do any harm to our body, and that forms complex with our metal which is giving damage to our body, and that should go easily. And here that penicillamine. Penicillamine is one of the one which is having a sulfur and which is having a nitrogen, sulfur, nitrogen, and which is having COO minus. And so here, what are binding sites? Binding sites are sulfur, nitrogen, oxygen. These three are binding sites which can bind with the copper which is present in the liver. Which can bind with the copper which is present in the liver. What happens? This forms a complex. After forming complex, this will again go through urine. So what is going to happen? Copper ion present in the liver is going to be out. It simply is coming out of the body. So in this way, we can remove the copper ions from the liver. Actually, if copper ions are there, what happens in general? We know that it will do some malfunctioning of the central nervous system, and so it should not be there. So in this way, this penicillamine can be used to remove the copper which is present in the liver and all. Moving on to the application of coordination compounds in cancer treatment. So very important example is cisplatin, excellent drug as anti-cancer. Anti-cancer drug cisplatin. So what is the meaning of cisplatin? Cisdiamine dichloroplatinum is also called as cisplatin, and it is a square planar complex. We have discussed a lot about tetrahedral, octahedral, square planar complexes in the previous classes, right? This is square planar complex, and cisplatin is one of the best drug which approved as anti-cancer drug actually. Since long time it's working very well, and this discovery opened an avenue for the complete history, and in the anti-cancer drug this played an important role. And there are so many, a series of platinum compounds, but all are not suitable for the anti-cancer drugs. One of this one is best one is cisplatin. And so many platinum compounds are there that are given here. This one, this one, this one, this one, and this one. So clinically approved platinum drugs are these things. And what is the function of this particular platinum drug here? Here we can see cisplatin, right? Inside body, if water will be there, that water will remove our chlorines. And here, and that cancer is causing due to the changes in the DNA. And this cisplatin is going to react with the DNA which is present in our body. What happens? The cisplatin will remove this water and forms a bond. Again, similarly, forms a bond like this. So this is the DNA. Our cisplatinum is going to form a complex like this. You can see here, right? This coordination leads to a significant distortion of the helical DNA structure, and that resulting in inhibition of DNA replication and transcription. So this will not allow that one to undergo any replications and all. So obviously what happens? So DNA will remain same, and it will avoid that chance of cancer and all. In this way, this will help us as anti-cancer drug.